Okay, so I have started recording this session. So how are you all? Been here for a long time now.
Good, sir.
Good, sir.
Okay. How's your holidays? Puja holidays? Things similar only. Yeah, they are in the home itself. So, okay, so after the last class, do you have any doubt, anyone? So if you have any confusion after the last class, you can ask. So do you recall what you have discussed in the last class? Yes or no? So in the last class we have actually we were discussing about all this came and followed at particular middle, and we have started discussing about different types of standard method of the follower that can be imparted, and for simple missions like the uniform velocity case already we have gone through that. Okay, we have seen how the displacement diagram, velocity diagram, and acceleration diagram for that particular case has to be drawn, and later on we have also gone through the modified displacement velocity and acceleration diagram for that particular case. Okay, so in the meantime, just let me know whether my screen is visible to you.
Yes, sir.
Okay, so now after that, we have started discussing about that simple harmonic motion, that type of motion of follower, and for understanding the friction motion of the particular follower, we have we have seen like when a particle moves on a particular circular path, okay, like this. Okay, here you can see from A to B. Okay, this is circular path that you can see. Okay, with this particular a particular angular velocity omega, then its projection on the diameter that is like this. Okay, if you do the projection here, and it makes the affection. So that particular logic we are going to utilize here. So later on we have discussed about your so later on we have discussed about how what is the you can say like when we are going to get the maximum velocity, what is the expression for or like the displacement. Okay, so here we have extended that y equal to x by 2 whole into 1 minus cos of phi omega t divided by yeah, okay, where this theta is nothing but what this angle of ascent. Okay, ascent is the follower is going up, in ascent stroke in descent stroke follower is going down. Okay, and what happens in the dual stroke? What about dual? What happens in dual? So there is no displacement of that particular follower, even though there is some motion of that particular thing. Okay, so this is the so from the expression for displacement, we have actually obtained the expression for velocity of the follower also, because we know dy dt that gives you the velocity, right? Similarly, after that, from the velocity expression, we have gone for the acceleration expression. Okay, there we have seen the velocity expression, that means it's a kind of sine curve. Okay, and for acceleration we have obtained that it's a cosine curve. And after that, utilizing those knowledge, we have also drawn the discussed how the velocity diagram has to be drawn for the fxn case, and how you need to draw the acceleration diagram for fxn case. Okay, so I hope these two are clear. So today we are left with the displacement diagram for fxn, right? Yes. So displacement diagram. So I believe all of you are ready with me. Okay, and I believe all of you have got your pen, pencil, etc. paper, so that you can try along with me. Yes. I hope that's a yes. So now for drawing the displacement diagram, okay, for a system, how to start? So once again, like we know that if we are talking about displacement diagram, then along the x-axis, what we draw? We show the cam angular displacement, it is a theta, and along the y-axis, what we show? We show the displacement or lift of the follower, right? So in that particular case, now you'll have a certain value of that particular lift or displacement. It can be denoted by x or y. That is depending on how what is the notation that you are using. You can use it. Okay, that is up to you. So now in that case, what happens here? How to draw the displacement? So up to this much, all of you are with me. Yes or no?
Yes, sir.
Okay. So if you have got your geometric instruments, you can do alongside. Okay. So now what we will do? First, this horizontal line we will draw. Okay. And in the horizontal, after drawing this horizontal line, here up as per some suitable scale. That scale is very important because these are all graphical method that we are talking about. Okay. So considering a suitable scale, we will be doing what? Suppose let's start it from here, and we have got different strokes. Okay, we have got theta a, that is the ascent stroke that we are talking about, denoted by theta a, that is the ascent stroke angle. Then we are considering we have the dual here after ascent, and after that we are considering we have got the descent stroke, and after that once again there is some dual is there. Okay, so now this particular horizontal line is draw. Okay, and as per certain scale, that scale will be like along this y x-axis we are talking about the horizontal line, that is the x-axis that you can consider. So along x-axis we are showing theta. Okay, and that as in a linear form we are drawing, that means some linear distance equal to some that theta, that is angular displacement of that particular cam that we are showing. Okay, so let's consider as if theta a, that is the ascent stroke angle, is suppose 30 degrees 30 degree, and for that suppose let's consider you are drawing suppose 6 centimeter as the scale. Okay, so in that particular case, scale you have to write along x-axis, or theta scale you can write. Suppose how much it will be? 10 degree equal to, that means along x-axis this 2 centimeter denotes 10 degree. That means 30 degree if you have to draw, then accordingly you have to do that. Okay, so whatever be the case, what some scale you will just consider, and accordingly you just convert, and you will mark it. Okay, suppose let's consider as per your scale this much is theta. Let's consider this 60-degree angle, and as per that suppose 6 centimeter you have drawn. Okay, considering 1 centimeter equal to that particular degree. Okay, so similarly, depending on whatever is the dual stroke angle, so let's consider this much is your dual, and after that let's consider this much is your theta d, that is the descent stroke angle. Okay, so next what we will do, depending on whatever is the lift that you have. Okay, that also, that is the along y-axis, that also you have to consider as per the scale, and one orthogonal line you are going to draw here. Okay, and you'll mark that particular distance. Okay, that is whatever is the displacement of the assembly that is there. Okay, so as per that we'll mark it, and you'll now close this particular rectangle. So these are all as per scale. Okay, and that scale needs to be stated. Okay, now here one interesting case. So this whatever is this particular thing that we are talking about. Okay, you can, if there is a dual at the end of the stroke, just like in this particular case, here we are showing that first theta a, that is which angle, then we have got dual, then we have got theta c. Okay, so and after that once again the second dual we have. Okay, this is the first dual, the second one. And this whole thing completes 360 degrees. That is one complete revolution. Whole thing is complete, considering up to the dual, it completes the one revolution. Now it is up to you. If there is a dual at the end of the stroke, you may or may not show it, because at that case there will be once again perspective. Okay. So now, so up to this much, I hope it's clear. Okay. So after that, what you will do, you'll just complete like whatever is this particular theta A, that is the SL stroke. So this SL stroke will complete. Okay, we'll draw another vertical lines here. Okay, so from here to here, this is the dual stroke, or you can say at the end of the dual, we have the beginning of the return stroke, right? Because first we have got the outstroke or the ascent stroke. At the end of the outstroke or the you can say up, outstroke or the ascent stroke, we have got the starting of the first duel. At the end of the first duel, okay, we have got the beginning of the return stroke, okay, and this is the vertical line we are drawing, and once again this is the already vertical line. So now these three boxes, it represents basically, this is the region of your ascent, this is the region for your dual, first dual, this is the region for your descent. Okay, and after that you may or may not make this particular box to for that particular. Okay, so after this much, all of you are with me? Yes, let me know. I consider that to be a yes. Okay. After that, what you have to do, you have to draw a semicircle considering this leaf as the diameter. Okay, so that means if that is the, then it will be the mid of the leaf will be, that means the center of this case. Okay, so now considering your using your uh, compass and all, okay, you will draw the semicircle here. Okay. So after that, what is to do? So we are going to divide those regions. Okay, this outstroke region, that is the ascent stroke, and the return stroke region. Okay, into certain equal space, even number of division, and similar number of division we are going to do in that particular semicircle also. Okay, so now the minimum that you should go for is like, we are talking about even number. Okay, minimum you should go for 6 division. You can also go for 8 division, 10 division, like that, but don't go for 4 divisions, because 4 division will be like, it is not going to give you any proper curvature of that particular curve that you require. Okay, and if you go for too many, you can say division, then it will be kind of time consuming. But definitely, if we go for more number of, more is the division, the better will be the, you can say, the curvature. Okay, the curvature of the particular curve. Okay, so it will be better smooth. Okay, so now our set consideration is 6 division. Okay, now 6 division if you are trying to do, then first we are talking about breaking 6 division here in this particular semicircle. Okay, now this semicircle is this 180 degree, so 6 divisions we are going to do equally spaced division. So 180 degree by 6, that will do, and accordingly using protector, okay, we will mark those division here in this section. So those who are listening, try along with me. Then it will be automatically some of the tasks will be offered for practice alongside, and give some name. So let's consider this is the equation, and got like each where we can calculate. You can see what is written here already. I am also putting them up. Patterns. Okay. So that's it. Now all those divisions, okay, we are going to mark. Okay, maybe with small letters and all. B, C, and uh, now all these divisions may be already you have. So I am using the same thing. Okay. So now, how many divisions, equal space division we have done here? We have made 6 divisions here. So now this essence stroke also, and similarly the distance stroke, we are going to make the same division here, same number of divisions. Okay, equally spaced. So if that was 6 centimeter as per your scale, then 6 division if you have to do, because you have done 6 division here in this particular case also. Okay, so you have to correlate them. That's why if it is 6 division here, in the essence stroke division also it will be 6, like that. if it is 8 division that you make here on this particular semicircle, here also you have to make 8 division, equally spaced division. So now we are going to go for 6 division. Okay, so now you'll just suppose depending on whatever is this particular scale, you'll just calculate it and divide it by 6. Okay, so then how much is the amount, that way you'll just mark here and draw those vertical lines. Okay, so now I'm showing like this. Okay, considering they are all equally spaced division. Okay, if it is 6 centimeter total, then it is like 1 centimeter, 1 centimeter each. I'm just giving an example. Okay, it's not like 6 centimeter it has to be. So this is for essence term. Now can anyone tell me, so this why we are making this division? Actually we are making this division like 6 division, 8 division, 10 division, etc. So that within whatever division we are making, okay, like let's consider number one, okay, this is first, okay, let's consider this is second, this is third, code, etc. Okay. So actually we are interested to get the value of the displacement, how they are behaving at this particular location. Now higher is the number of consideration of those different locations, better will be the curvature that you will get. Okay, better will be the accuracy algorithm. Okay. Now that is about outlook. Okay, how the displacement will be there for different interval of time. Ultimately if at different camp location. Okay, so now from here to here it is 12, right? So now can anyone tell me, is there any requirement of making any division here in this 12 so as to get the exact camp, like you can say position of that particular uh, follower? Is there any requirement of it? That is how it is behaving throughout the 12 first 12. We want to. So is there any requirement of dividing it just like your essence stroke? The answer is no. Okay, because why? So we know that in dual basically there is no displacement of that particular follower. Whatever will be the previous position of that particular follower will remain here, even though the cam will rotate by certain angle. So now that particular angle is nothing but this dual stroke angle, and whatever is the previous position of the follower, it will remain there. So no displacement. So even if you make divisions here in the dual stroke, it will, the follower position will remain the same throughout. Okay, so there is no meaning of making this. Okay. Next, after that, at the end of the duel, we have the starting of the particular T system. Okay, so once again, depending on how many divisions you have done here, okay, similar is number of even number of divisions equally spaced you are going to make here. Okay, so once again, 6 division equally spaced division we are going to make in the theta d, that is the descent stroke angle. Okay, so already the descent stroke, how much it will, what will be the length, those things already as per scale, as per the considered scale already been done. Okay, so we are making the division here. Okay, and after that we have got another duel. So once again we are not going to make any division here. Okay, we are interested in how the follower is moving, how the what kind of displacement is there in the follower during the ascent stroke. We know there is no displacement of the follower during dual stroke. Once again we are interested in knowing what is the follower, how the follower is moving down, that is in the descent stroke. Okay, previous one in the ascent stroke, dual, then the descent stroke. Up to this much all of you are with me? I hope yes. Okay, so now to get the location of the displaced position of the particular follower at this, that is 1, 2, 3, this intervals, how we are going to get it, just be attentive here. Okay, so already 6 divisions we have made here, so accordingly we have made 6 divisions here in the theta A as well as theta B. Okay, so now whatever with the first division reference this particular point. Okay, so from here you will just draw horizontal line, that is the first division here in the semicircle, first, second, third, fourth, fifth and sixth. Okay, so accordingly we also have first, second, third, fourth, fifth, sixth, six division. So first with first, second with second, third with third, like that we will see. Okay, so from the first one we will try to draw one. You can either draw from the first to on first division to the first vertical one only up to this pass, or you may extend also, extend up to the descent stroke, because ultimately in the descent stroke also we need to locate the point. So you can, from this side you can extend up to descent stroke also, and it is, or the same thing could also be done by drawing a semicircle here in this side also. If this second stroke also is a SHM stroke, right, like this particular case, sometimes it may so happen that in a same problem you may have SN in a, let's consider SHM, SN with SHM, suppose let's consider descent with simple hurdle, other type of apart from SHM, maybe information and all. So in that particular case, so now to locate the interest point of interest, how to check? Okay, so the first horizontal line with the first vertical wherever they meet, that is the first point. Okay, so for our case, which will be the position, this is the position. This is the first vertical, this is the first horizontal. Similarly, from for getting the second point, so from the second position of the semicircle, actually we have to draw a horizontal line. Okay, you can either draw up to this first, or you may extend also, because in the second, in this side also it is required. Okay, so similar is the case. This is the third position. So third to third vertical. So from here to here. Similarly, from fourth position to the fourth vertical, 1, 2, 3, 4. Okay. Similarly, from the fifth position to the, right now these two figures doesn't overlap because drawing in laptop is difficult, so I'm trying to do that. Okay, and sixth is six after this, from six to six. Okay, now we have got those located these points. Okay, now what we need to do, we have to draw a freehand curve. We have to join those particular points with a freehand curve. Okay, so now starting from A, this is the start position. We are going to join those with the required curve. Okay, and up to Z it is done. Because Z is the last sixth division. Okay, so this way also you can draw, or as I have already said, okay, this division line should be kind of not that much dark. Okay, so you can do one thing, you can extend also, no problem. You can extend also, but you need to properly take those or locate those points and get some name here. Okay, located points. Because this is B, this is C, D, and so on. Okay, after this much all of you have understood, let me know.
Yes, sir.
Okay, thank you. Now after that, what is this outstroke or the ascent stroke is over. After that, what is the name of the stroke? We have dual now. Okay, so now dual means what? There is motion of that particular cam, but during that time there is no displacement of that particular follower. Now already the follower at the end of the ascent stroke, it has moved up to this position. Okay, so now throughout the duel, sorry, not descent, there will not be any motion of that particular or any displacement of that particular column. Okay, so now with a we darken it up to this point. So this is the portion of that particular column. This during duel. Okay, now here the duel ends now. Okay, now at the end of the duel, which position, which stroke starts from the end of the duel? Now the return stroke. Okay, return stroke starts. Okay, or the descent stroke. So now, as here in this particular case, both the stroke, it is the ascent stroke as well as descent stroke is with FHM. So the way of locating the points will be similar, but now it is going down. So from this side, it will come. Okay. So this line, this horizontal lines, if you just extend, then it will also cut in the uh, this return stroke or the descent stroke also. Okay, and from there we are going to just locate those points. Okay. So once again, same case. So this first particle is the first line. we have given 1 dash, 2 dash, 3 dash like that divisions. Okay, so always give some nomenclature. Okay, so first horizontal is the first vertical here then. Okay, look at that. Similarly, second, this is the second vertical and this is the second horizontal. They are intersecting here. Okay, similarly, this is the third vertical, this is the third horizontal. Okay, they will intersect here. Similar is the case, fourth vertical, fourth horizontal, fifth vertical, fifth horizontal, and this is the sixth vertical and the last sixth horizontal. Okay, so this is one. So starting now, it is going down. Okay, returns has started. Okay, so we have to locate those points. Okay, join those points with a freehand curve. Okay, smooth curve. So don't join the points like this, 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 like this. Rather, you try to follow the pattern of the curve. Okay. So now starting from here, these are not straight line. Okay. Right now my figure is not going to good. Okay. So this is straight line. Okay. And this is about the return stroke. After that, there is two. Okay. So this is how we complete it. Let me know you have understood. I hope it's a yes. Okay. So then actually after drawing the displacement diagram, we go for velocity and acceleration diagram. But already in the last class, we have discussed how to get the velocity as well as acceleration diagram. Okay, for this particular case. Okay. So it is basically a Shm motion that is also actually over. If any confusion is there, we can ask. So we have seen that this velocity curve, is a sine curve. Okay, acceleration was a cosine curve. Okay, now here I have this written down the particular steps for whatever I have already discussed. Okay, steps for drawing the displacement diagram for a section. Okay. Now if you have any questions, just in case in the trial, currency, etc., then you can ask. Since no, if no, then we will go for the next type of motion, that is the uniform acceleration and uniform retardation. Okay, so now here, actually uniform acceleration and uniform retardation, it says that basically in a single stroke itself, okay, we have got uniform acceleration and uniform retardation. Half of the stroke is with uniform acceleration, half of the stroke is with uniform retardation. Okay, so that's okay. So once again, we'll just consider as if we have got like your first ascent, then the drill, then we have got descent stroke. Okay, and we are going to draw the displacement diagram for that particular case. Okay, so now we know how to draw the displacement diagram along x-axis. What we have to consider. Hello, anyone? Along x-axis for the displacement diagram, we have to consider the theta, same angular displacement, and along y-axis we consider the displacement. Okay, so now for drawing the for constructing displacement diagram for uniform acceleration and uniform retardation, what we do once again will be those who are listening properly try to draw along segment. Okay, once again the horizontal line has to be drawn. So we are going to so the almost theta. So we are going to mark the theta. Theta can angular displacement. Okay. Now depending on once again what is the value of that particular theta A or theta B, that is a stroke angle, this stroke angle, we have to use the scale properly. Okay, this is very very important in any kind of graphical method. Drawing the or showing the uh, drawing is very important, and writing down the proper unit system is very important. Okay, so now as for scale, we are going to cut out that theta A and 12 and theta B from your case. Similarly, theta b. Okay. So now from here it has started application. And from here we have the benchmark theta a and theta b. Okay, as per the scale. Now what we will do, considering the lift or the stroke, we are going to draw a vertical line here. This AU, this particular line. Okay, and we are going to complete this particular rectangle. Okay, I hope it's clear. Now once again, what we will do is theta A, that is AH here, and theta B, we are going to divide them into some equally spaced even number of. Okay. So now once again we will consider, let's consider 6 division that we are going to make for theta A as well as theta B. You can have different division for theta A as well as theta B also. Okay, one suppose for theta A 6 division you can do, for theta B you can go for 10 division, etc. etc. Okay, that is possible. Now what we are going to do is 6 division we are considering now. Okay, so after the theta A as well as theta B, for drill there is no need. Okay, already we know. So now we are going to make 6 equal space division here. Okay, so from this 6, if the outline already the third division is there, so 3, 6. And don't forget to give some names to those points. Okay, like H, G, I, J, etc. Okay. Now you know that this is the uniform acceleration and uniform retardation that we are talking. Half of this is uniform acceleration, half of them is retardation. Okay. Now whatever is the number of division that you have done here, that is here in this particular case, 6 divisions. Okay. So what you will do, you will just take the mid line, mid vertical line. So in our case, this will be the third one. Okay. So this is the middle, and in the vertical wise, we are going to mark the same number of division equally spaced. Okay, this is six division you have considered now. So six marking, equally spaced marking you will do here. Okay, and the first three you are going to join with the left side, this side. Okay, starting, and next three with the end side. Okay, so with a straight line. So from the origin, this is straight line. This is the and this is now actually the for this form. Okay, so actually they should have like here. Okay, because curl, that is whoever it is. Okay, so this third one. Okay, so the third one from this side as well as from that side will coincide. You will see automatically if you have drawn as per scale, you will automatically see. Similarly, for the next four, next third, okay, we will draw from here. So that means if I draw from here, they will automatically become same line. Similarly, you are joining this division with coordinate and this. Okay. So now first for locating the first 3 points, what you will do, just like the previous case, first line with the first vertical, second line with first, second vertical, third line with third vertical, wherever they meet, those are the points. Okay, and you are going to name all those points. Okay, so now here it is first with first vertical, we have got A. So you can either change your from here, okay, or you can locate here, no problem. Similarly, for locating the second point, we already have this second line and we already have this second vertical line. So where they meet here. So this is the next point of interest. For getting the third one, okay, this is the third landing line or incline line, and this is the third vertical line. And where they meet here. So this is the third. Similarly, for fourth case, this the fourth particle. Fifth case, this fifth particle and this line joining it, okay, and this is the point. Now, and sixth is directly this B point is C. Okay. Now, what we have to do with her? What? What we are going to do? Anyone? We have located the points. Now, what is your task? Now, starting from the origin, okay, join those points with a freehand curve and ET. Okay. So that is basically about drawing the distribution diagram for info acceleration and info acceleration test, and we have drawn for with stroke only the outstroke. Okay, then stroke or the outstroke center. Okay. After that we have 12. So for the dual, there is no need to make any kind of division. You don't have to bother about that because there is no motion of that particular follower. If there is no displacement of the follower, there is no discussion about velocity and acceleration in that case. Similar is the case for the descent stroke, but it will be in the opposite direction. Okay. So I believe if you try it, you'll be able to. So now, how to draw the velocity diagram? So for drawing velocity diagram along x-axis, we already know. Once again, the theta will be there, but along y-axis, now velocity will be there. Now this is what's in uniform acceleration and uniform retention. That is half of the stroke uniformly accelerated, another half uniformly retarded. Okay. So for that case, so this is we are projecting those points. This is the midpoint. These are the two extreme points. This is the starting of the ascent and end of the distance. Ascent, sorry. After that, this one is once again 12. Okay, and once again we have got another ball. Okay. Where initially it is the retardation. We have obtained retardation, and after that there is some acceleration. Okay. So that's why it is going up like this because it is uniform now. After that, it is going down. After going down, there is still so there will not be any movement of that particular uh, your this particular thing. Okay, but particular thing means that particular follower we are talking, but it will remain here. And after that, once again, same thing happening, but in the opposite direction. Okay. So if you have all of you have understood, then we will almost stop here for today. And if there is any question, you can ask. So I wish that all of you will be practicing alongside me. Otherwise, I'll just be telling you everything and you will not practice, then it will not be effective. Okay. So if you have any question, you can ask. Otherwise, I'll be taking the attendance. Seems like no question. Okay. So respond to your name calls. Nilupal,
Present, sir.
Shankar, Shankar, absent. Arshisman, Arshisman, absent. Rohan, Rehan, sorry. Rehan Ansari, absent. Partha,
Present, sir.
Rishikesh Busumotari,
Present, sir.
for Permit,
Present, sir.
Lohosol,
Present, sir.
Eza, Eza, in fact absent, he was joined and not here. Rishikesh not,
Yes, sir.
and Emil.
Yes, sir.
Okay, so thank you everyone for joining. We'll meet in the next session. If you have any
Thank you,
question, you
sir.
can ask.
Thank you, sir.
Thank you, sir.
If no question, we'll stop here.